G'day viewers. In episode 2 we presented a method for quantizing gravitational acceleration over the Fourier domain. Since producing this video I have read statements claiming that, quote, that's not how to quantize stuff, end quote, or, quote, that's not how gravity is quantized, end quote. In this episode we're going to respond to these positions by broadly discussing the concept of quantization. That is, what is it and what does it mean when people talk about quantization. The first thing we'll do is look at the Apple Mac Pro Dictionary version 2.2.2 definition of quantization. Paraphrasing, it states that, in terms of physics specifically, the process of quantization restricts the number of possible values of a quantity or states of a system so that certain variables can assume only certain discrete magnitudes. In other words, a Fourier distribution which contains an amplitude spectrum and a frequency spectrum, both of which are quantized via the integer harmonic sequence 1, 3, 5, 7, 9, 11, etc., satisfies Apple's stated definition of quantization perfectly. In terms of electronics, the same dictionary defines quantization as the approximation of a continuously varying amplitude to one whose amplitude is restricted to a prescribed set of values. In other words, the amplitude spectrum associated with a Fourier distribution also fits the electronics definition perfectly. Hence, our claim regarding the quantization of gravitational acceleration at a mathematical point in a gravitational field is definitively valid across the entire electrogravity magnetic construct. So then, now that we have by definition demonstrated that we have quantized gravitational acceleration over the Fourier domain perfectly, why do many physicists seem to have a limited understanding of the meaning of quantization? Well, it seems to be for three main reasons. Number one, any method of quantization a physicist hasn't seen before is summarily declared to be incorrect without giving it due or thoughtful consideration. I have encountered this phenomenon multiple times. Number two, physicists are taught what to think rather than how to think. By contrast, engineers are taught how to think, not what to think. In other words, engineers focus on solving a problem rather than attempting to find a unique solution pathway to a problem like many physicists do. Number three, the reality of the technological world we occupy is that there is always more than one way to skin a cat. There is never a single and unique approach to any engineering challenge. However, physicists seem to believe that there is only one way to skin a cat and consequently only one way to approach a problem, and typically it needs to be an approach used by an historical scientific figure. Allow me to give you a practical example of what I mean. There are three main types of automotive power plants, that is, electric engines, petrol engines and diesel engines. All three transportation variants utilise entirely different physics. Try filling a petrol engine with diesel fuel and see how far you get. What I'm communicating here is that many methods of quantization exists and there is always more than one way to skin a cat. As long as the method applied satisfies the dictionary definition of quantization, then whatever variable has been quantized in accordance with the definition is by definition quantized. So then, what's the bottom line? The bottom line is that a Fourier distribution, also known as a Fourier series, is a fully and completely quantized phenomenon. Hence, our approach to quantizing gravitational acceleration in episode 2 is definitively correct and irrefutable as per the Apple Mac Pro Dictionary version 2.2.2 definition of quantization. Therefore, our method for quantizing gravitational acceleration across the Fourier domain in episode 2 has been applied correctly and appropriately in order to validate Bob Lazar's 7.46 Hz gravity B wave frequency claim. When you get the opportunity, we recommend watching the YouTube video appearing in the link at the bottom of the screen. This demonstrates some of the many possible examples of quantization explained by the Perimeter Institute for Theoretical Physics.